I'm Jack Diederich. This talk is Class Decorators Radically Simple. I'm a big fan of class decorators. I used to use meta classes, but I didn't necessarily like doing it. Class Decorators gives you a lot of the same options, a lot of the same power, but it's human readable and human writable. So first, a remedial slide. Decorators, many of you, they've been in since 2.4 for functions. Many of you have used them. At the top is the decorator syntax. It's just syntactic sugar for the pair of lines on the bottom. All a decorator does is it takes a function as an argument and returns something, preferably something useful, preferably something that has a similar signature. If you've used function decorators, you've probably used them in classes. Static method here is a decorator. The expansion in the bottom, this is what you'd have to do before Python 2.4. You define the function first, then replace the function with that function after it's passed through static method. Class decorators. Class decorators are new in 2.6 and 3.0. They work exactly like function decorators, except you use them on classes. So at the top, we have the new syntax, which is the decorator definition, the class, in this case empty, and at the bottom is the expansion. You could do all this before, you could do this in 2.3, you could do this in 2.2, but now we have syntactic sugar. The practical definition of a decorator is a function that takes one argument, and that argument is a function or a class, the thing being decorated, and returns something useful. If it's a class, it should return the class, hopefully the same class, or at least a class with the same interface. If it's a function, it should be the same function, or at least one that has a similar functionality, something useful. So you can't say that Jack lied to you. Here's the formal definition of a decorator. It's a little bit longer than the practical definition. A decorator is a callable. A callable is anything that can be followed by the parentheses function call syntax. That can be a function. That can be an object that has the double under call method defined. That can be a class's new method. Must accept at least one argument. It will only ever be called with one argument. It can accept more optionally. It can't require more. It can't require keywords. And it doesn't have to return anything useful. It just has to return something. Every callable in Python that doesn't throw an exception returns something, so this isn't a high hurdle. So let's whip through some valid decorators. This is the simplest decorator. This is the radically simple of the title. If you ever have to think of decorators, think of this one. It takes one argument and it returns one thing. This is the identity decorator. It does nothing, but it doesn't break anything either. So it always returns whatever it's given, so it replaces what it's given with what it was given. Very straightforward. In the middle, we have the identity decorator actually being used. Define an empty class, decorate it with identify. At the bottom, we have a little interpreter output. C is still C. It's the same thing you'd typed if you hadn't decorated at all. The hello world decorator, not a useful decorator. This is a valid decorator. But this should get you into the idea that you really can do anything in the body of a class decorator. It's not always wise. People might curse you for it, but you can do anything. So this takes whatever it's given and returns the string hello world. Same thing, in the middle we have an empty class C, decorated with the hello world. And as you can see at the bottom, when we go to look at C, it's just the string hello world. Slightly stranger, but to reinforce the fact that you can do anything in the body of a decorator, we have replace with X. This takes a class, defines a new class, X, in the middle of the decorator and returns that instead. Don't do this, people won't like you. But it is completely valid, and it begins to give you an idea of the fact that you really can do anything in a decorator. So in the middle, we have the definition of the empty class. We call the decorator replaced with X, and as you can see, what happens is C is replaced with the class X that was returned from the decorator. A little stranger, we have the instantiate decorator. All this does is calls its given argument with an empty arg list. So you might want to call this one singleton. Wouldn't recommend it. But again, it's just something different you can do and gets you out of the mindset that it has to be exactly what you were given. So we have the empty class, instantiate is called on it, and we end up with, instead of the class C, an object that is an instance of C. A little bit more complicated, but still based on the instantiate decorator. The decorator that we're going to use in this case is still instantiate, but here it's wrapped. So we have the outer function decorator maker. It's the thing immediately after the at, but that's not actually the decorator. It's returning a function that is the decorator. And in practice, you'll see a lot of decorators are defined this way. They take optional arguments, use those to build a decorator function. That gets returned, and then that actually gets called on the actual thing to be decorated. So at the bottom, we have the interactive output. C is an instantiated object, which we do here. It's the same instantiator decorator. But C.args comes from the decorator maker function. So those args were captured there. Then when the decorator was called, they were given to C as its init arguments. This is the bastard operator from hell decorator. To further demonstrate all the wrongness and evil that you're allowed to do in the middle. Here we have hello world, which takes any number of args and once again returns the string hello world. The bastard operator from hell decorator defines a new class X, uses the hello world function as its meta class. Another reason that meta classes are complicated is there's probably not a dozen people in the room that know that hello world is a valid meta class. Uses that as its meta class, reassigns slots, and then as its get attribute, it takes, every time you call get attribute, it returns something random from the dictionary. So you really can do anything in a decorator. So bonus points if you know what the output is about to be for this. That's what C becomes. I can talk about why later, but yeah. So evil stuff. You don't have to do it, but... So decorator history. As I said, function decorators went into Python in 2.4 as syntactic sugar. The compelling use case was static method, class method, that kind of thing. Also memoize, which kind of caches the results of functions. It was pretty clear what people were going to be using function decorators for. There was a long argument about including class decorators at the time, but Guido's general thing is you can't take things away, but you can always add them later. So we waited till later. Meanwhile, I wrote a patch to add class decorators in 2.4. 2.4 was released, it wasn't applied. Updated the patch for 2.5. 2.5 was released, and it wasn't applied. Then finally, in 2.6 and 3.0, we have class decorators. Middle, we have the grammar for decorators. It really is the same thing. What you know about function decorators also applies to class decorators. A decorated class or a function is simply a list of decorators between 1 and a million, followed by a class definition or a function definition. If you know how function decorators work, you know pretty much how class decorators work. The decorators are applied in order from nearest to farthest, unpeeling the onion. And so that's just def or func, a name, and an arg list. So at the beginning I said I like class decorators because they're so much easier than meta classes, but you can get a lot of the same kick out of them. The first thing that makes them much easier is the interface. So again, we have the identity decorator, followed by the identity meta class. So this is the barest meta class practically you can write that will do the same thing as ob, return ob. There's some gotchas in meta classes. I've been writing Python for 7 years. I still have to look up the difference between the first argument to new and init. It's not the same. it's important if you're doing stuff. So basically, meta classes are harder, seem more like black magic. You can do an equal amount of black magic in class decorators, but people rarely do. Let's see. All right. So where things are in class decorators versus meta classes is also different. Decorators move things outside of the class definition. In this case, we're doing a cron schedule. Something runs nightly on something called sales report. So the class decorator moves this bit of information outside the class. The sales report doesn't need to know when it runs. Only the cron needs to know when it runs. If you're doing the same thing with meta classes, which is what I used to do, you have to hide information inside the class. You have to add the meta class or perhaps know that it's included in report. Things become more hidden, less obvious, and you intertwine metadata about the class with the actual class data. So again, to emphasize, class decorators, there are definitely two class decorators on this slide. How many meta classes are involved with these two? You don't know. You'd have to look it up. Typically, you'll find out after the fact when your class has extra attributes or is doing something that you didn't write or didn't know about. Then you have to go back and look at class Z, see if class Z has a meta class, see if class C doesn't have a meta class. Is it inheriting from a class that has a meta class? You have to go all the way up the stack. Class decorators, although they don't inherit, announce themselves loudly, which makes them much more readable. Decorators are also stackable. I don't know if Alex Martelli is here. He will tell you that meta classes are inheritable. Yes, he has a nice little recipe for combining meta classes. This is obvious to one man, and that man is Alex Martelli. But for the rest of us, it's very easy to stack class decorators that have nothing to do with each other. Here we have one cron schedule. Run this class nightly. Here we have another one, arbitrary. It says document this at the top level. These are moved out of the class. They don't interfere with each other. You don't have to have a recipe for multiple inheritance of meta classes. Versus mix-ins. They're really not much different from mix-ins if you want to use them that way. I've just never particularly liked mix-ins. The Dick methods, which I'll get to later, class decorator is actually a copy of user dick mixin with a couple extra if statements and some nesting changes because there's a couple extra if statements. Mix-ins is where you have a class that has a bunch of default functions, default implementations for things, and if you don't override them in your class, you just end up inheriting those. A class decorator that does the same thing defines a bunch of functions, a bunch of default implementations, and then adds them before it returns the new class. In the case of dick mixin, if you have getItem defined and keys defined on a dictionary-like class, then all of a sudden you can do keys, or you can do length, you can do iter values, you can do copy, you can do all kinds of things if you just define a couple primitives on a class. Popular patterns. Some of these are actually meta-class patterns. The first uses for class decorators were replacing what used to be done with meta-classes. We're actually starting to see some uses of class decorators in the wild now, so the list is a little bit longer. So I'll go over these briefly. Register, which is like that cron scheduler I showed you. Augment, which is kind of the replacement for mix-ins. Take a class, augment it, return it. Fix up, you could call it the monkey packaging decorator. We'll get to that one too. And verify. We'll do verify first because I don't like it. One thing people used metaclasses for was paranoid framework authors. They were terrified that someone would define an object and try to put it into their framework and it wouldn't work quite right. But instead of waiting until it failed, they'd do it up front and have some asserts and kind of put their foot down. And so here we have a class decorator, assert candy. And all it does is checks that a couple things are defined on the class. If you do any kind of testing, unit testing, then please ignore this, don't use it. If you don't do unit testing, please ignore this, don't use it. Registration pattern. This was actually my killer app for getting class decorators into the standard lib. I used to do all kinds of stuff with metaclasses, and it gets ugly, it hides information. So again, we have the cron scheduler, and I had a file with 50 of these in it, and they were all of the kind of metaclass format. But the cron scheduler out up top, again, it removes information from the class body that doesn't belong in the class body. You get to see, obviously, whether each class in the file is being scheduled, when it's being scheduled. Everything is up top, up front, and very easy to use. Augment pattern. This one actually came out of PyCon UK. Raymond Hettinger dared someone to write a new and useful class decorator, and this is what some of the guys came up with. The implementation will be later. So total ordering takes any class that defines less than or an equivalent method. Once you have less than, you can define equals, not equals, greater than, all the other methods. So all this does is whip through and uses less than to make all other comparisons valid. So here's an implementation of the registration decorator. You have a factory, your cron scheduler. You just want to add items to it one by one. It's a simple class. All it does is keep a list. It has a method register to add things to the list. Later on, if you want to go back and see what's in it, just look at the all attribute. That's everything that's been registered. In the middle, we have animals factory, create a new factory. It's just an instance of this class. And animals register. Register is a function that takes one argument, a class. It's a bound method, so self is given. Takes one argument, class, returns the class unmolested. So you can see this is very similar to the identity decorator, except for the fact that it's doing a little work in the middle. Registration metaclass. This is simpler than this. And Doug Napoleone, when he saw this slide, he said, "My God, that's the simplest metaclass I've ever seen in my life." And I said, "That's okay, it's a lie. There's more." So this is the kind of thing that you would have to do to make a new registration metaclass. It's actually a function that creates a new type on the fly and returns it. So inside the function, we define a factory metatype that has an all attribute. And every time a new class is defined, it gets appended to the all list. But then we have to do that little, instead of return class, we have to do all this good stuff so it's a valid metaclass signature. And then return the factory meta. So to do the same thing, we create a new factory and then have to include it as a metaclass in the class where we used or one of its parents. Here's part of the lie. I couldn't fit the whole metaclass on a slide. This is extra. So when you use a class decorator, it fires once. You can see exactly where it happens, exactly where it's applied. There's a big at in front. It says its name, and it's executed once, and that's that. With the metaclass, this will be run anytime someone inherits from that class, anytime someone inherits from that class, then inherits from that class. So if you ever want something in that chain to not register itself with the factory, you have to do things like put a big hack flag in the middle that says do not register equals true. So my code actually has littered in it, or used to before class decorators, classes that have this big old flag in the middle. So this is actually pretty close to the implementation of the total ordering decorator. The actual decorator has a couple if checks and won't automatically overwrite things. But you can see it's a decorator. It accepts one argument, which is its class, and it returns one argument, which is that class after it's been modified. Pretty simple. Add a bunch of methods. Each one is defined on either the less than or the method right above it. Fix-up pattern. This is what I call the kind of monkey patching decorator. If you have Java or C++ people that really like to use private attributes for no good reason, double underscores, then you can throw this decorator at it, and it will automatically turn them into single underscores. And then you can happily go along using their grep library and never worry about it. So here's stop writing Java in use. So we have our Java class with our secret attribute. Throw a stop writing Java at it. No problem. We can access secret with a single underscore. And at the bottom is an example. Since decorators are just functions, you can also use it to monkey patch their library. So best practices for class decorators. Return the original class, although you can return anything, especially if you have stacked registration decorators. Each of them will believe that they saw the one true class. So even if you other decorators add or remove to a class, you shouldn't do anything like create an exact copy of that class that is different, that is the same in every respect, but its actual ID. You won't make any friends. Similarly, don't assume you're the only decorator, which goes along with returning the original class. Maybe you do want a meta class. I knock meta classes some of this talk, but I actually do use them still. I just use them much less. Don't add slots. This is more a warning than anything else. One of the popular-ish uses for meta classes was people saying, hey, the same kind of people that think they should use a meta class because meta classes are neat, think they should use slots because slots are neat. Don't do it. What else we have? So links, my slides aren't up yet. They will be by the end of the lunch. Here's some other links. Here's a discussion of the total ordering decorator from back when it came out. And the functools module has some fix-up functions and some other utilities if you're running function decorators as opposed to class decorators. All right, any questions? Huh? Yes.
So I have a class decorator that queries a class to add new arguments or stick arguments in so you don't have to add them. And that's using the pattern of having an internal function that's querying and then returning the function. So now the class isn't a class anymore, it's a function, and now I can inherit from it. It's kind of a pain in the ass. Is there, what I wind up doing is like, I don't use the decorator, I instead have I declare it with an underscore in front, and then I declare the main one, passing it in, and then I can inherit from the one with the underscore in front.
Something like that?
Yeah, something like that. So is there something better than my stupid hack? Is there some way to inherit from something where you're querying it like that?
You could, it would violate one of the things I said, return the original class, but you're not returning the original class anyway, so it's less of an issue. You could redefine init. So if you already know what the first argument that you're going to call init with is anyway, you could define a new init in the class decorator that assumes that first argument.
Okay, so if I have a very stable like set of arguments to the constructor, then I can override init and.
Well, you could define a new class in the class decorator, and that would be an exact copy of the original class, except for the fact that you would write a new init dynamically that assumed the first argument, that took one less argument to its init and knew what the first one should be.
Okay.
I can do it out for you.
I'll talk to you again.
Yeah. Any other questions? No?